We start with the quiz that you see here, simplify this expression, which is much like the expressions that you would have solved for homework, would have simplified. The idea is very simple. You factor everything and then you divide out like factors. Now, process of factoring these things, well, that's something that we did a couple of weeks ago, so you might need to review that a little bit. Okay. So we have x squared plus 4x plus 3. Well, that's x plus 3 is x plus 1. So this factors into x plus 3 times x plus 1. The denominator factors into x plus 2 sorry, it's x minus 2 times x plus 3. And then that's multiplied by x plus 1. Then x plus 3 is a factor of the denominator and a factor of the numerator. Same thing with x plus 1. And doggone it, the same thing with x minus 2. This equals x minus 2 times x plus 1 times x plus 3. Again, our x minus 2 goes here, x plus 1 here, x plus 3 here. Just putting the factors in order of the numbers, -2, 1, and 3. And you don't have to do it that way. And that equals 1. Because the numerator is the same as the denominator. When you divide an expression by itself, you get 1. Now, if this had been just a little different, let's say we had the expression you see here, which is just like this one. Actually was just like that one. We're going to change one thing. Changes x plus 1 to an x minus 1. Okay, different problem now. It's not the same because they don't have the same factor at the end of the denominator. X squared plus x plus 3. Factors into x plus 1 times x plus 3 as before. But now we have x minus 1 where we had x plus 1, so that the x minus 1 is not going to divide the x plus 1. Now this could be written as x minus 2 times x plus 3 times x plus 1 divided by x minus 2 times x plus 3 times x minus 1. Then the x minus 2 and the x plus 3 are the same as the x minus 2 and the x plus 3 in the denominator. So this equals 1 that we get when we divide the x minus 2 times x plus 3 by the x minus 2 times x plus 3 in the denominator. It's 1 times x plus 1 over x minus 1. . Okay. Now, a lot of people will do something like this. When they get to this step, it's where people cancel a factor of the numerator by the same factor of the denominator. So if we have x plus 1 times x plus 3 times x minus 2 divided by x minus 2 times x plus 3 times x minus 1. The x minus 2 here is a factor of the denominator, and it's also a factor of the numerator. So open math will tell you just cross a line through them. I don't recommend this until you're very sure you understand the rules, and I'll tell you why in a minute. And then we can do the same with the x plus 3. X plus 3 and x plus 3 are both factors of the numerator and of the denominator. What's a factor? Again, it's something that's multiplied by everything else. It's not something standing over there alone with a plus or minus sign on it. It's something that's a part of the multiplication that you do to get the numerator or the denominator. Okay, so this is okay. This is not okay. X is a term in the numerator. It's not a factor of the numerator. I don't have room to write of the numerator, denominator. Not okay. However, as many times as I explain this, a significant minority, probably even a majority of people, will still do this, which is why I don't talk much about cancellation. Going to use cancellation, make sure you understand the rules. This equals this because this thing gets divided by this thing and they're both the same and they give you 1. Okay, can rearrange it so it's clear that you're dividing all this by all this. You can even put an extra set of parentheses around it if you like, to indicate S is going to divide that. Okay, this divides this. Now, last time we actually went over addition. of rational expressions, where you have to find the common denominator and so forth. So in order to do that, you're often going to have to factor things. You're going to have to reduce the numerator and the denominator of each expression to its factors, which means you're going to have to be able to factor trinomials and factor out monomials, which we learned to do last week. Okay. So make sure you give that some attention. And really, when you can add expressions like this, you really know something. It's kind of a semi-advanced topic in Algebra 2. So it's worth knowing, worth being able to do. Okay, now we're going to switch gears a little bit. Okay, first thing I want you to remember is I'm not going to be here next time. Okay, I have to drive my wife to a medical appointment in Johnson City. It's a very important appointment. One tomorrow and one the next day. I hate to miss class. Her sister-in-law was going to drive her, but her sister-in-law's having kidney stone surgery today. So our daughter's driving her today, but she can't do it tomorrow and Wednesday. That's a situation. I'm not missing for any trivial reason. Or not trivial. And I don't know when the last time I missed a class was. It might have been a decade ago. And that was either car trouble or some stupid thing. Okay. And so far, knock on wood, I've never had to miss being sick, ever. So if I don't knock on wood, I'm going to probably come down with COVID, RSV, flu, and some kind of skin condition for next time. That's the way fate works. Okay, digressing back. Remember, I won't be here, but I will be posting a video, and I expect you to work through that video as if you were in class. The only difference is I'm not going to be able to come around and give you hints and keep you moving, and I won't be able to adapt the video to what you're doing, which I usually do in class. And look at what you're doing, I think of what you need next, and we go from there. Okay. Well, at this stage, let me check one more thing. Okay, just wanted to make sure I had the assignments understood. But for next time, you multiply rational expressions. And two things like what I had up there, you multiply them. Well, you just put the numerators together. You just multiply the numerators, then multiply the denominators, just the same you do when you multiply fractions with numbers. Then you simplify. Okay. And when you simplify, of course, that's when you've got to factor everything and get rid of common factors. Then there'll be an assignment due when you come back from Thanksgiving break. Actually, I think that's when you come back from Thanksgiving break. I better check that again. Yeah, there'll be an assignment when you come back from Thanksgiving break. And Monday, it's coming Monday, we'll go over that assignment. If you happen not to be here, like if you're traveling to Outer Mongolia for Thanksgiving, you probably want to leave early. But be here if you can. But I'll be posting that video, which will give you a little more information on what you need to do for the assignment that will be due the following Monday. Part of it will be adding fractions, which we already covered. and people did pretty well with in class. The other part will be the quadratic formula, which you really need. It's pretty easy. You got to practice with it a little bit. There was an assignment on function notation, and I'll probably mention that because it's good to know that before you get into pre-calculus, because it's the first thing in a pre-calculus course that kind of throws people for a loop. Pretty simple, but if you see it earlier, it's less likely to throw you when you see it later. So that's kind of the plan for the rest of the semester. What I want to talk about now is one of the really important topics. So I'm going to go back to linear equations and give you a linear equation to work on. So let's see if you can solve that fairly quickly. Okay, now, I just said this, but we're seeing that people are a little shaky on this. They're doing a lot of the right steps, but they're doing incorrect operations at some point. Or, you know, everybody did something incorrect at some point, even though most of the ideas were pretty good. This is something everybody was able to do on the midterm just a few weeks ago. And my comment was that if you're not able to do it today, it means you didn't really learn it before midterm. Okay? You learned something. Because again, I'm seeing a lot of things, but it's not nailed down. And this is something that you cannot enter a pre-calculus course with if you can't do it. Okay? As badly stated, you can't enter a pre-calculus course with the inability to solve linear equations and quadratic equations. So we'll do a little bit with quadratic equations. And then I'll kind of tell you where you need to go from there. Okay, so anyhow, what do we do? There are two rules from you multiplying or for solving linear equations. You know how to multiply the same quantity on both sides? Multiply or divide both sides, same quantity. Now I'm going to give you problems for practice, okay? And they're not going to be open math problems with videos and everything, okay? You need to become independent of that help. And I'm going to recommend to become independent and to understand this as quickly as possible, that you write out this. It says add or subtract same quantity both sides. Okay, you could abbreviate that. You could do add, comma, subtract, same Q both sides, or just QBS. No, you don't want BS in there. Okay, understand? I would recommend you write it all out, except maybe using a comma instead of the or. And multiply or divide could have a comma there. Both sides, same quantity underlined here, both sides underlined here. Because I've seen errors on that just today, okay? You have to understand that these are your rules and that you're applying them when you are applying them, okay? Okay, well, to start this problem, a lot of people started by subtracting 5 from both sides. I think everybody did. All right, there's a little error on that, on some of the work I saw, but some of it was really good. But you really want to do the distributive law first. Okay? So I'm going to write here. We can abbreviate it. You don't have to write out all those letters. Distributive is a lot to write. Okay, distributive law, abbreviated, means that we have 3 times x minus 3 times 2 plus 5 equals 6 times x plus 6 times 3 minus 7. Now, it only takes about 5 seconds to write out this step the way I did, where we're emphasizing what the distributive law states. And then simplify. I just write SIMP. Once you write these things down, once you write down what you're doing at each step, I think it will stick with you much better and clarify the nature of the process in the rules that you use. And we'll simplify just means, okay, we're going to multiply 3 by x, and we have minus 6 plus 5, then we have 6x plus 18 minus 7. There's still some simplifying we can do. We have negative 6 plus 5 here, which is negative 1. And 18 minus 7 is 11. Now we have an equation. It's really simple. And all you have to do is add 1 to both sides, subtract 6 from both sides, and do a little division. Now, if I'd have given you this equation originally, I'm pretty sure everybody would have gotten it right. Okay. To get from here to here, we just follow a couple of common steps. We use the distributive law, we simplify, and then we simplify again because first simplification, just do these multiplications, and then we got to do these additions or subtractions. And then you write aha when you recognize you have something really easy. I recommend you actually do that. Okay? Or at least a couple of exclamation points to indicate an aha moment. Because when you see this, you know that you're home free. Now, if you don't know that you're home free when you see this, if you do a few problems of this nature, you will know, okay? You'll begin to see how things funnel down into a simple solution. Okay, so we have 3x minus 1, so we're going to say add 1. I'm just going to say add 1, both is enough, because you know that means you've written the word both, so you don't forget to do it on both sides. Because many people will just add 1 over here and not add it over here. Now, the way people are often taught to do this is you put 1 equals 1 here. And I said, well, I want to see that equal sign. Open math doesn't emphasize that equal sign, but you're adding an equation to an equation. This is a true equation, 1 equals 1. If it isn't true, boy, we're in big trouble, okay? Maybe we're in big trouble anyway, but 1 isn't equal to 1. Whole foundation couples, okay. This equation here is completely equivalent to this equation. It's just in simpler form. What I mean by completely equivalent, any solution to this equation is a solution to the original equation, if you've done your steps correctly. Okay, well now, we go ahead and add 1 equals 1, that's safe. If you add a true equation to a true equation, you get a true equation. You get 3x minus 1 plus 1 equals 6x plus 11 plus 1. Now, if you don't write out this step, you could easily fall into the trap of trying to add the 1 to the 6, because 1 is right under 6. But you can't add 1 to 6x because you don't know what x is. X could have any infinite number of values. 1 has only one value. So if you add 1 to one value of 6x, it's not the same as if you add 1 to another value of 6x. And it sure ain't 7x. Okay? Except for one possible value of x. Okay, well, what do we do here? We simplify, just do the arithmetic. Now, I think everybody knows that you don't subtract the 1 from the 3 here. Make sure you're adding numbers to numbers and variable quantities to variable quantities. Like terms to like terms. So we get 3x equals 6x plus 12. And then subtract 6x both. That would be sufficient. Tell me what you're subtracting and doing it on both sides. So we're going to put a negative 6x here equals negative 6x. And we get 3x minus 6x equals 6x plus 12 minus 12, minus 6x, not minus 12. Okay, so the minus 6x appears here, the minus 6x appears here. And we get negative 3x equals 12. After we simplify. And I write divide both by negative 3, meaning divide both sides by negative 3. We get negative 3x over negative 3 equals 12 over negative 3. Simplify that. Negative 3 divides negative 3 gives you x. 12 divided by 3 is 4. And since you're dividing a positive by a negative, you get a negative 4. There's our solution. Well, we're not done with what I want you to do. I want you to check. Check the solution. Here you've got this. And we substitute x equals negative 4. We get 3 times negative 4 minus 2 plus 5 equals 6 times negative 4 plus 3 minus 7. And we're going to simplify this. Well, that's negative 4 minus 2 is negative 6. Negative 4 plus 3 is negative 1. Okay. And now we simplify again. 3 times negative 6 is negative 18. 6 times negative 1 is negative 6. And we simplify again, we get negative 13 equals negative 13. Put a big underline and a check mark. Yippee, hooray, whatever it takes to express your joy in having solved this problem correctly and in detail. Okay? Now, if you do, say, 20 of these, the first one might take you 5 minutes. Or if you don't really understand and you got to slavishly imitate everything here, it might take you 10 minutes, but the next one's only going to take you 5. The next one's only going to take you about 2 minutes. And by the time you've done 20 of them, it'll be within, you'll be infected. It'll be in your bloodstream. But it's a good infection, okay? And it'll take you about an hour. If you're slow, it might take you a multiple of that. It might take you an afternoon. Be worth it, okay? Because it'll take you away toward really understanding the mathematics, writing it out. I'm not going to require that you bring it to me, but I wish that you would. I would like to see it, and I'd like to see that you come in here, say on Monday, and do one of these in a couple of minutes. I don't know how many problems I'm going to give you. If 20 problems isn't enough, how about I give you 20,000? Well, that's not humanly feasible, and I'm certainly not going to ask you to do anything that's not humanly feasible. Okay? Yeah, pretty good, but I don't know that you're superhuman. Okay, fair enough. We superhumans understand these things. Right. Okay. So I'll probably give you like 100 because I'm just going to write a little algorithm that generates a bunch of these. And if you want more than 100, all you got to do is, if you want 1 million, I'd send you a file with 1 million. Okay. The first several will give you whole number solutions, but then I'm going to start giving you fractional solutions. And you might run into trouble when you plug fractional solutions in. Okay. So maybe I'd better give you a little heads up on that. Now, really all I've got to do is just make one up with random numbers, and it's almost certain to give me a fractional solution. So I'm going to take a chance and do that. Okay, so let's try. I'm going to need plenty of room. Okay, that one ought to be ugly enough. Okay. So first, I'm going to write add same thing to both sides, multiply or divide both sides. Okay. So first thing I'm going to do, I'm going to apply the distributive law. I'm going to get 4 times 7x plus 4 times 5 minus 17. I'm going to do this kind of fast so I can make a mistake and discover it. If I accidentally do everything right, well, that's kind of okay. And I'm gonna write down everything as I think it, and I'm not even gonna double check my thinking, okay? Because we're gonna check the solution, and I think there's at least a 50-50 chance that I'll screw something up, and the check will reveal that I did. Okay, well, simplify 28x plus 20 minus 17 equals 27x minus 18 plus 14. Simplify. I add the 20 to the negative 17. I get negative 3. Now I get 27x minus, oh, heck. How could this happen? I'm going to have to change my problem a little bit. As I told you, if I just randomly write numbers down, I'm not going to get a whole number solution. This is going to give us a whole number solution. It's going to give us x equals negative 7. Okay? Because when I subtract 27x and 28x, we're just going to get x. You know, we have a whole number over here. That's irritating. So that doesn't happen. I should have checked that this times this wasn't close to this times this. I just decided that these numbers should all be relatively prime. And relatively prime numbers, thought, we'll be okay. All right, well, let's see. I'm going to change this to an 11x. Then I'm going to go through. I've only got to change a few terms. Okay, 9 times 11x. Might be hard to read, but that gives us 99x. Now I know that's not going to give us a whole number. Okay. So same steps as before, but I've got an 11 here. Relatively prime and ain't going to give us anything but a fractional solution. The denominator is going to be 71, I think. Okay, now subtract 3 both, which means I'll add the equation negative 3 equals negative 3, and it's going to give me a true equation. I'm going to get 28x plus 3 minus 3. Right out this step equals 99x minus 4 minus 3. As a matter of fact, if you wanted to skip the step where you write negative 3 equals negative 3, and just write this, you could, because you have your 28x plus 3, then minus 3, and your 99x minus 4, and a minus 3. You've appended minus 3 on both sides and didn't really need to write this. But there's benefit to writing this. But at some point, and when you're confident and when your checks are all working out, if you want to just skip from here to here and say you subtracted 3 from both sides, well, it's clear that you did. And if your check doesn't work, then you say, oh, I missed that step. I did a bonehead thing. Maybe I better go back to writing this a few more times. All right, so anyhow, here we are. We have this, we simplify. 28x equals 99x minus 7. Okay. Subtract 7 both. I'm tempted to write subtract 7 BS, meaning both sides, but I don't want to inject BS into this course any more than I already have. Okay, so we have 28x equals 99x minus 7. I'll do what everybody seems to be in the habit of doing that is really kind of unnecessary. But we get 28x plus 7 equals 99x minus 7 plus 7. First place, I don't want to subtract 7. And if I subtract 7, I'm not going to add 7 like I did. And adding 7 wouldn't get me anywhere. Okay? I was too busy with the BS to both sides thing. Okay, so we subtract 99x on both sides. So we get 28x minus 99x equals 99x minus 7 minus 99x. 28x minus 99x is negative 71x. 99x minus 99x gives us 0. We get negative 7. So x equals negative 7 over negative 71. Well, actually, we don't want to skip a step. We simplify this and get this. Divide both sides by negative 7. We get 71x over negative 7. 71x over negative 7 equals negative 7 over negative. I told you I was going to make some bonehead mistakes. You don't want to divide by negative 7, divide by negative 71. And we simplify that. Negative 71x over negative 71 is equal then to negative 7 over 71. Negative 71x over 71 is just x, because the negative 71 divides the negative 71 one time. And the negative 71, well, negative 7 over 71, negative 71 is negative over negative, which is a positive. Now we check. We have 4 times 7x plus 5 minus 17 equals 9 times 11x minus 2 plus 4. We substitute x equals 7 over 71. And we get 4 times 7 times 7 over 71 plus 5 minus 17 equals 9 times 11 times 7 over 71 minus 2 plus 4. Now, I'm not going to use the distributive law yet. You could, and it would not be incorrect. Okay? It's going to be kind of messy. It's less messy if you simplify what's inside the parentheses. 7 times 7 over 71. 7 times 7 is 49. 49 over 71 plus 5 minus 17 equals 9 times 11 times 7 is 77. Minus 2 now plus 2 plus 4. The one thing we don't want to do with equations is have denominators and have to do common denominators. Okay? So we're going to avoid common denominators. And now I'm using the distributive law. And then we can simplify. 4 times 49 is 196. Nine times 77 is 770 minus 77, which is 693, I think, over 71 minus 18 plus 4. Simplify a little more. You have 196 over 71 plus 3 equals 693 over 71 minus 4. Okay. So now we just have a fraction plus a whole number, fraction minus a whole number. And I say multiply by common denominator 71. So we have 71 times 196 over 71 plus 71 times 3 equals 71 times 693 over 71 minus 71 times 4. Well, 71 times 196 over 71 is really easy. That's 196. 71 times 3 is 223, 213, sorry. 71 times 693 over 71 is 693. And that's minus 284. So 196 and 213 is 409. 693 minus 284 is 409. Yippee. We just checked it and we know it's true. Now, writing out this thing when you got fractions is a fair amount of work. But you need to be able to do fractions. Okay. And the central point here is you don't ever put everything over a common denominator. You get it down to this step here. We've just got 2 terms on each side. And then you multiply both food by 71 and all the denominators go away. You get some kind of big numbers, but you got calculators, you can calculate. Okay? That makes sense? All right. So that's the kind of thing I want you to practice. You know, try to get you some problems. But of course, you do have an open math assignment to work on for next time. Okay? Which is just multiplying fractions. That's pretty simple, as long as you can factor. So make sure you're good on the factoring. Review what you did on factoring. It'll make your assignment much easier if you do that.